Have a look at this particular table. It is shared by Snowflake for any new account in the Snowflake sample data database in the TPCH SF1000 schema. By far, this is the largest schema in the TPCH suite of schemas. If you see here, if you have a look here, I'm in data preview, and for this table alone, we have over 6 billion rows. Yeah, 6 billion rows, and this table alone occupies on disk over 159 gigabytes, so almost 160 gigabytes. What we'll do here, what we want to see here, okay, we'll have a look at, let's see, we'll have a look at the number, at the distinct values. Yeah, we want to count the distinct values in this particular column, L ship mode. Yeah, so just remember we have 6 billion rows here, and yeah, as you can see here, there should be just a bunch of values for distinct values for ship mode. Later on, what we'll do, we'll repeat the same, count the distinct values, but we'll group by. We'll group by, let's see. I'm just looking for other two columns with just a fewer values. So I will pick up L discount and L return flag. Okay. And you'll see why, but keep in mind this table because we'll use it for our test. Back to our project, I separated here, yeah, side by side, similar tests, similar queries. On the left side, what I have, I will count the distinct values with this particular expression. Count distinct, and I will pass, yeah, the expression in this case, yeah, you'll see for us will be the column name, yeah, the ship mode, and something similar on the right. Instead, that I will count the distinct values with this particular expression using arrays. So I will use array unique aggregate. Yeah, array unique aggregate. If you pass here a column name, will create an array with all the distinct values. And what you want for the count is just to call array size, yeah, to wrap everything into array size, and you get something very similar with a count of distinct values. But Snowflake recommends that in some specific cases, and we'll talk about this, array size array unique aggregation could be more performant than calling count distinct. When exactly? Look, I selected this schema, that yeah, this large schema here as current context in both screens. I executed before select distinct, yeah, select all distinct values for LSHIP mode uh, on both sides, yeah. So I apply select distinct, yeah, on the left. On the right, I did this with array unique aggregate, yeah, in the whole table, okay, just to pick up the unique value. So yes, this took 51 seconds here and 34 seconds on the right, yeah, with array unique aggregate. But we cannot conclude anything at this stage, yeah. Then I just applied the select count distinct, yeah, for this for the same column, yeah. It will always be the same column, ship mode, yeah. And this was very fast on the left, yeah. This was acceptable, but slower, yeah, definitely much slower on the right. Once again, we shouldn't conclude anything because you have some specific pruning, yeah, that Snowflake is doing on the back, and specifically it may save, distinct values in a specific column. So this value here could be cached eventually or deducted in a performant manner anyway. So this applies to the whole table, remember. So, but the fun begins now. Yeah. We'll do something similar, except that we'll introduce a group by our other two columns that we identified with fewer values. You remember we have a return flag and a discount. And we'll do the same here, except that, as I said, the count distinct will be replaced on the right side with array size of array unique aggregates. Okay, but the query will remain the same. And yeah, they perform basically in the same time. Yeah, 92 seconds, 94 seconds. Okay. At the end, yeah, we try something different. We tried a group by with a roll up using the same two fields. Yeah, because just to keep it consistent. Yeah. And yes, we could feel the improvement here. Look, the table with count distinct took about 206 seconds. So this is more than 3 minutes. More than 3 minutes. While the query on the right took just about 1.5 minutes. So this was twice as fast. And look, you can execute these queries by yourself. I'll not do it here because, yeah, these are trivial queries. They return a bunch of values. Uh, I advise you to do it just to double check that you may get slightly different times here, slightly different results. Yeah, but the point is that at some point, array size, array unique aggregate could perform better for this kind of queries, group by grouping sets, roll ups, or cubes. So here is a conclusion. Yeah, what Snowflake recommends that in some specific for some specific queries, you can rather use this call on the right side: array size, array union, AGG. That's a built-in function. These are both built-in functions for arrays, and you pass a column name here. So basically, this applies on a bunch of rows. Yeah, that belong to a column instead of the typical count distinct that you have on the left side. Because those queries may perform better. What kind of queries are we talking about? We're talking about hierarchical aggregations. Yeah, they call them hierarchical aggregations, and these are basically group by queries with multiple columns using either grouping sets, roll up, or cube. We had our demo with Rollup, and I encourage you to use some other samples using grouping sets, cubes, and eventually more than just two columns, and to compare the results. I remind you that array unique AGG, that's a built-in function for arrays. You pass a column names there. You can pass an expression that returns just a set of rows with one single column, basically. And what I suggested here is that you pass a column that returns rows with these specific values. Let's say 5, 2, 1, 2, 3, 1. And what array unique aggregation does, it will return one single array, yeah, because it's an aggregate function. It will combine all the data found on different rows into one single value. So it will eliminate the duplicates, okay, and it will return just the unique values, the distinct values. Uh, why is this better, in these specific use cases? Is because you can produce the arrays once at lower levels and reuse them in higher aggregation levels, yeah, in these specific hierarchical aggregations. Okay, so you may get an improved performance and your query may execute faster. You can further improve, the performance using materialize use or just persisting the intermediate arrays. Yeah, you can persist the immediate arrays that you can collect from different rows. You can persist just the array with no duplicates returned by array union, AGG. Okay, and be aware that as a main limitation, you cannot build an array with more than 16 megabytes, yeah, in Snowflake. Basically, you cannot return any cell in any query or store anything which has more than 16 megabytes, yeah, per cell. In this case, Snowflake recommends to eventually use alternatives, and one of the alternatives is with bitmaps. Once again, refer to the documentation if you want to find out more.